Another rational function. I took the liberty of factoring, building a sign graph for the y values. I differentiated, sorry, I've already erased my work, found the zeros of my numerator and approximated them. I want exact values, but just so I get the placement correct, I did provide myself with some approximations. And even built a sign graph for that first derivative function. So let me try to put things together, but this is a rational function. So let's see if you and I can put a lot together prior to even looking at my calculus tools. Now, if you don't mind, in this example, I want to clearly sketch the graph, label all intercepts and asymptotes, just label the x-coordinates of the local extrema, and let's not worry about inflection points. Knowing what I know from basic pre-calculus, the zeros of my numerator are going to give me the location of the x-intercepts. The zeros of my denominator are going to give me the locations of my vertical asymptotes. My y-intercept is located at 0,6. And because the degrees upstairs and downstairs are the same for those polynomials, I get a horizontal asymptote of y equals some constant, where that constant is just a ratio of leading coefficients. So clearly I get a horizontal asymptote at y equals 1. Now, if you don't like the way I said that, don't listen to me. You could take the limit of this rational beast, multiply top and bottom by 1 over x squared, you get the same answer. The limit equals +1. If you don't like that approach, you can use L'Hopital's rule to evaluate the limit. Use it twice, but you're going to come up with the same value, +1. Now, to the right of, hold on. I put the vertical asymptote there, so my intercepts are a little bit outside of that. There's 3,0, here's -2,0. Who cares if I'm off scale? I just want the relationship to be correct. Now, to the right of that x-intercept, my y values are positive. So I know I'm going to have to be increasing, but I've got a horizontal asymptote at y equals 1, so I'm going to start hugging from below, I think. Maybe not. Maybe I pass through the x-intercept and pass through the horizontal asymptote and start hugging that horizontal asymptote from above. I don't know. We'll find out in a minute. Between the vertical asymptote and that x-intercept, my y values are negative, but I got to be hugging that vertical asymptote from the right-hand side. Now, between these two vertical asymptotes, my y values are always positive, and I have to hug those asymptotes. I think I behave something like this. I think. But I could be wrong. I'm kind of suggesting my local mins at the y-intercept 0,6. That could be a little off, but I'll fix it in a minute. Now, between this x-intercept and this vertical asymptote, my y values are negative, and I have to hug that vertical asymptote. To the left of this x-intercept, my y values are all positive, and I have to hug that horizontal asymptote. I either behave as such or as such. So I've done the best I can with the tools of algebra. Now let's look at the first derivative function. Notice how I get a sign change from positive negative about an x value of -10. That must mean to the left of this x-intercept, I change from increasing to decreasing. Therefore, I guess to the left of that x-intercept, I do not behave in solid fashion, but that dotted fashion. Now I'll fill it in. And that local max occurs at an x value of -5, minus 2√6, and I'm too lazy to find the y value. Now, notice that I'm decreasing thereon after up to that vertical asymptote. But on the other side of the vertical asymptote, I'm also decreasing up to an x value that's kind of close to -1/10. And then I start increasing. So I guess I got a local min at that x value, which is approximately -1/10. So I guess I don't behave as such. I don't locally min out at the y-intercept. I must locally min out to the left of it, and then pass through it and hug the other vertical asymptote. That local min right here is located at -5 plus 2√6 comma something. Again, I'm too lazy to find the something. So I'm positive in that local min up to that vertical asymptote, but I'm also strictly positive to the right of vertical asymptote, and so I can't behave in the dotted fashion, or otherwise I'd be violating the sign graph. So I guess I behave in the solid fashion, not the dotted fashion. So can you appreciate how I kind of had a rough idea what the graph looked like with my tools of algebra, but finally, I've got some tools in my back pocket that allow me to fill in the finer details on the graph of that rational function.